And another example of graphing parabolas, and this is f of x equals 1/4 x plus 4, or x plus 1 to the 4th, x minus 2 squared, x minus 5. So we got a lot of zeros here. We've got 4 zeros. Any factor, if any one of these factors is equal to 0, the whole product will be 0. So negative 4 will make this 0. Negative 1 plus 1 is 0. 2 minus 2 is 0, and 5 minus 5 is 0. So these are my zeros. X equals negative 4, x equals negative 1, x equals 2, and x equals 5. So we'll put this on our graph. We can also find the y-intercept. Let me put the zeros here. So negative 4, negative 1, 2, and 5. So those are our zeros. Okay. And my y-intercept, well, that'd be f of 0. Okay, that's going to be on the y-axis. So I'll put 0 in for every time I see an x. So this is going to be 1/4. 0 plus 4 is 4. 0 plus 1 is 1. 0 minus 2 is negative 2. 0 minus 5 is negative 5. And that's going to be 1/4 4. 1 to the 4th power is 1. Negative 2 squared is 4, and negative 5. And 1/4 of 4 is 1, so that's nice. So I just have 4 times negative 5 is negative 20. So there's my intercept. So what I did was I made my scale by 5, so I have negative 20. So there's my intercept down here. Now let's check the end behavior model. That's to be the g of x, and all we do is just add up the exponents. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be x to the 8th. And that's going to be positive even. So it's going to behave like x squared. So it'll behave like this, up and up. So I know it's going like this and like this. Okay. All right, and multiplicity, this is 1, so it's going to be crossing, so it's going to come down here, so it's going to be crossing. Now here at negative 1, it's even, so it's going to do a bounce. And here at 2, it's also even, so it's going to do a bounce and return, or touch and return, bounce. And at 5, it's going to cross, and that's going to match my behavior, so that, my end behavior, so that makes sense. And between these 2 points, the low point will probably be, I'm just estimating, between about 1/2. So it's going to probably cross the intercept and do something like this. Now I don't know how low it's going to go unless I put 1/2 in there, so I'm just going to make an estimate. It's going to go like this. And I think we have enough to do it. I'm not going to find these other high points. I'm just going to guess on those because it's a lot to put those numbers in here. It'd be a lot of work. You could do it, but without a calculator, it'd be kind of a lot of work. So it's going to come down like this. So I figure it's going to cross here like this, and it's going to come even a little bit farther and come back up. It's going to go like this, curve around here. Now I don't know how low it's going to go, so I'm just going to make it go a little bit like that, and there we go. So something like this. With the information we've got or the work we've done, this is about the best you can do. So there's your function. It looks complicated, but it's pretty easy, isn't it? It's just if you know what to do. And again, we can't really find these low points or these high points, which we actually call those relative extreme values. You know, valleys and mountains, we call those relative extreme values. And we can't really check those relative extreme values unless we put points in. And when you learn calculus, you learn how to deal with that, how to find those exact points here. But we don't do that right now. Okay, so there's your function, and that's not too bad, I think. So take a look at that, try to think through it, make sure it all makes sense. It's nothing too difficult, just a lot of little things you got to do.